Well, hello students. I'm going to go over with you getting started on doing the percent yield calculations. They're pretty straightforward. Some of them, though, you do have to do a stoichiometry calculation. So you can see on the page. I'll zoom in a little bit more for the first part. But as you can see, we got the equation. Percent yield is how much you actually obtain from a chemical reaction compared to how much you figured out in theory. Then you got to times that by 100. And so let's see, number one right here. Oh, and there's a YouTube video that's kind of set up very similar to these that you can also watch if you don't want to watch mine. But so on this one right here, you calculated this many grams of gas would be formed. So this is the calculated. After the reaction, you recovered only this much. So this is the actual. I like labeling these things. I recommend you too do that. And we've got the equation here. Now for this one we don't really need the equation yet because the percent yield equation, we have it up there. Percent yield is going to equal the actual mass obtained, and we said in this one it was 0.42 grams of gas, and that's actually O2 gas if we want to be really specific. We calculated, we need that in the denominator. In this problem, we had previously figured there should be 0.50 grams of O2 produced. And then you need to multiply that by 100 to get the percentage. So I'm not going to do the math for you. You can do that. The next one, again, pretty similar, straightforward. You predicted this much. So I'm just going to label, I'm going to label calculated. It's just easier for to write calculated than predicted. So that was the calculated. You only measured, this was our actual, only 1.3. So what's the yield? That's the only one you have to do here. Well, percent yield equals, okay, the actual mass, which we said the actual was 1.3 grams of antimony is what SB is. And we calculated, we need that in the denominator. You figured there'd be 1.5 grams of antimony. And then you're going to get a decimal, and you're going to times 100 to get your fraction. Okay, on these, a little more involved, because you have to actually do the calculation. First two, we didn't do that. I'm going to leave this part of the MVP triangle, the double triangle. I think that's really helpful. So let's see. When potassium chromate is added to a solution of 0.500 grams, I'm going to make the decimal bigger, so 0.500 grams of silver nitrate, we get 0.0455 grams of silver chromate formed. So in this problem, we're going to eventually do the percent yield, but right now we need to calculate. Now, when we read this problem, this is our given right here, okay? So this is our given. We've got 0.5 grams of silver nitrate. Now I'm going to come down here. Silver nitrate is this one. I'm going to label this given because we're going to need to do the mole to mole ratio in a moment, and the given will be really helpful to know which one that is. Now it says over here that only 0.455 grams of silver chromate is formed. This is what they said was formed. We're going to have to find by calculation how much silver chromate in theory there should have been. So this is our find, and silver chromate, well, let's see, silver, and there's chromate. Yeah, that's silver chromate. This is what we're trying to find. So we're going to have to first do a full stoichiometry calculation to figure out what the calculated amount is, and then we're going to use that as our so our given in this problem is going to be 0.5 grams silver nitrate, AgNO3. That's our given. That's going to go over 1. We always want those to go, and that's where we're starting right here. We're starting down here at grams of a chemical. And then the next step we need to do on all of these, we're going to have to change the grams of the chemical into moles. And we're going to have to divide by the molar mass of silver nitrate. Now, fortunately, I asked you all to do that. Silver nitrate is 170 grams per mole. So 170 grams of AgNO3 is 1 mole of AgNO3. So we got that one set up okay. Now we've got to do the mole to mole ratio, and it might help you on there. Let me just momentarily zoom in on that a bit. Moles of compound B. This is the chemical we're trying to find, so that goes on the top. Moles, this is the find, what we're looking for. And then this is the given side of the MVP triangle over here. Actually, I should write it here. And so you want that divided by the moles of compound A, which is the given on the bottom. So it's the find over the given. Let me zoom back in. Okay, so now we need to do the mole ratio. We need what we're trying to find over what we're given, and we do that from the balanced equation. Now we're trying to find Ag2Cr4, and there's the coefficient there is just a 1. 1 mole Ag2Cro4. And the given in this problem, well, the given was silver nitrate. We can see that here. We also label it there. But we need the number of moles. There's 2 moles of silver nitrate in the balanced equation, AgNO3. Okay? Now, being able to diagonally cancel here lets us know we set this up right. And the moles of silver nitrate there should diagonally cancel down there. And now we've successfully, in this MVP triangle, we've jumped over here. We just need to change it now to grams. So the last step is we need to, following this, once we get to moles of the fine compound, to change it back to grams, we need to multiply it by the molar mass over 1. So, and that's over 1 mole. So I'm going to go ahead. Oh, I'm catching on something there. 1 mole of the silver chromate, CrO4, is going to be how many grams of Ag2Cro4? Well, I don't have that off the top of my head. You've got 2 silvers. I know silvers are 108 because we've worked out, so 2 times 108 for the silver. Chromium, let's see, is 52 grams. So we've only got 1 chromium in there. Yeah, just 1. So plus 52 grams for the chromium. And then we've got 4 oxygens. Each oxygen is 16. And let's see. Well, let's see. Clear. 16 times 4 equals 64 grams. So you have to add that up. Put that in there. And then you will get your predicted. We will now have, this will equal so many grams of Ag2Cro4. Hopefully I didn't go off the screen up there. I didn't. This now, in your percent yield, this is our calculation, okay? So you're going to put this answer, or got to times 100. Whatever your answer is here, that's going to go down there. And we set up here the actual mass given in our problem is formed, so 0.455 grams. I would recommend you go to 3 decimal places here since we kind of did there. So that's how you do that. Now I'm not going to go into the detail for the rest of these. I'm just going to help you with the given and finds. Okay, so same kind of a problem. We're looking for the percent yield, so there's 2 calculations we're going to do. First the stoichiometry. So this is going to be our, says we got 13.1 is actually produced when this many grams is heated. So I know it's kind of hard, but this, okay, this is what the given is, because this is what we found. This is the chemical we're going to try to find. This number here is the actual. We're going to figure out, we got to figure out the percentage, the calculated. This is our given. Okay, so we are given 28 grams of CaCO3, calcium carbonate. So CaCO3, I'm going to label this, circle this one here. This is our given. And since we're looking for the percent yield of CaO, that's what we're trying to find. So I'm going to come circle that over here. Oh, look at that. Everything's a 1-to-1 ratio. Okay, that'll make everything easier. Find. Oh, yeah, find. That's what we're trying to find. Okay, same thing. you're going to have to put the given is 24.8 grams of CaCO3. That's the trickiest part here, making sure you know what the given is. And then it's the same steps you did here. You just got to use the molar mass for calcium carbonate, and then at the end for calcium oxide. And let's see, I'm pretty sure, yeah, we got one of those on your sheet. You've got it on number 13 for calcium carbonate. I don't think we did calcium oxide, so you have to figure out that one. So, but you know you're going to have 3 calculations, with this being the ratio step. Then once you get that answer, same thing there, you got to do the next calculation. For number 5, if you're having trouble with that, let's just read through it. If 50 grams of silicon dioxide is heated with an excess of carbon, so they're saying we got plenty of carbon, okay, it results in this many grams of silicon carbide formed, okay. What's the percent yield? Okay, now since this is our actual yield here, silicon carbide is what we're trying to find. Silicon Si, carbide C, so it should be silicon, there we go, SiC, that's going to be the silicon carbide. And they're saying 50 grams of silicon dioxide, silicon and 2 oxygens is heated. So this is our given over here, so I'm just going to circle this. Silicon dioxide, this is our given. This is our find. Okay, so since this is our given, we're starting with 50 grams of SiO2, and then you're going to go through, change it into moles, do the mole ratio, change it back into grams, and you're going to find the calculated answer. And then you've got to do the next step, the percent yield, just like we did in step 1 and 2. Okay, lastly, 15 grams of nitrogen reacts with hydrogen gas with this much ammonia. Okay, so they're telling us this is what we're trying to find, is the ammonia. This is what we actually got of ammonia in the lab, so we got to do the calculation. This is our given. So nitrogen in the balanced equation is in the form of N2. I'm going to circle that and say this is our given. And we're looking for ammonia. That's ammonia. That's what we're trying to find. And you know what? If you didn't know what the chemical formula was, you could have got your phone or your computer and said, what's the formula for ammonia, and would have found it. So, once again, you're going to have the given over 1, 15 grams. Now, be careful. It says nitrogen in the balanced equation. It's N2. So you can make sure you put 15 grams of N2. Change that into moles of N2. Then you're going to do the mole-to-mole ratio here. Then you're going to change the moles of ammonia back into grams by multiplying by the molar mass. And you're going to get the calculated yield. Then you'll use your equation up above. There you go. Done.